Thank you very much giving an opportunity to presenting the talk about fly ash and waste to wealth. This is a very peculiar topic, and we will highlight how this waste material going to be wealth in Indian scenario. So basically, the fly ash is the major waste product by thermal power plant in huge quantity. Millions and million tons of fly ash is produced by the single thermal industry. As per the survey of Central Electricity Authority, March 2016, fly ash includes substantial amount of silicon dioxide, then Al2O3, calcium oxide, and other minerals. Have you pointer? Pointer? Or we have like this. So if you go the worldwide scenario, we can see the India is the highest production of our fly ash, whereas China is the second. Can you do that? Okay. So if you see the India is going to be more than 150 metric ton per year, where the China is second. If you see the utilization is only nearly 40%. So this 60% unutilized fly ash is going to be in our environment, soil, health, and many more. So how we can use this waste material to a useful material? The challenge. Government has given a strategy to have a fly mission to fund different research projects. They have made a partnership with Russia also. Even though India fly ash utilization is very less, and still this has become a fly ash pond. Some fly ash due to the rain coming to the water through water, and again soil is going to destroy. So this is the major problem environment sector, agriculture, as well as if you see the industrial meant a rule near the thermal plant power 300 kilometers, you have to use the fly ash because transportation of the fly ash is a big problem. So to reduce the cost, this is made compulsory to have fly ash made of brick, so that the construction can be used. Road also they can use, but even I can say still we are far from the utilization of fly ash. So I am going to give a scope to the research scholars as well as the scientists how we can mitigate or how we can use the fly ash more and more, so that this fly ash waste material going to be a useful product for the humankind. How much time, madam? Okay. So okay. So this I am skipping it. No problem. So you see this basically the fly ash, we have the pot. I am going to skip with those things. This is summarized one figure. So this is we have the power plant. This fly ash particle coming here, and this is going to the air, and this is because the hazardous material like cadmium, yeah, all these particles are. So this is going to be inhalation, and this is problem in the health. Then also the animal, the soil, groundwater going to contaminate, soil going to contaminate, plant also going to, and this overall going to affect the human. So this is cycle channel of the how is going to be a unwanted things way. How can doing the material, because we cannot stop the growth of the Indian or the world by the power plant. If power plant is stopped, we cannot get energy. So we require the energy by the thermal plant. At the same time, the coal quality. So we are getting the more ashes from the coal. So India also getting import from the outside coal because they have less ash content, even though the ash is coming as a major part of the Indian thermal plant. So if you see the generation, this is basically the data Overall number of thermal power 146 is 132 here, and install, you see the coal consumption 272, here 251, and fly ash utilization you see here 48.65, here 48.87, and overall the fly ash utilization is still 53% only. If you see the estate wise utilization, this is the idea, you can get it here. Overall in Delhi very less production, so you can get here Delhi very less, 112 point. But if you go other states like Uttar Pradesh, or you can get West Bengal or Odisha, still these are for the fly ash utilization. The major utilization of this in a cement, brick and tiles, mine, arch deck, roads, agriculture, concrete, these are still. But if you see this utilization is significant, so we have to find a new kind of product. This is, we can able to show how we are going to use these fly ash. This is basically the Central Electricity Authority data 2016 they published, we get it, and this clearly shows that still we have not utilized fully the fly ash. So I am going to give you some glimpse what we are working about the fly ash. Typically use of the fly ash in cement is nearly 44%. I am going to escaping these things. If you see here the data, the generation of this here blue color, and we are utilizing this. So far behind the utilization of the fly ash. So this photograph you can see the cement is 41.97% because we have the construction, and in the cement earlier we have the ordinary Portland cement using, now they are putting the fly ash. So in fly ash this is a maximum utilization of cement, but still we are not able to cover the 100%. So how can use the more and more fly ash? So if you can find some, the I think the DST and other government part is ready to pay the things, any product, tiles or any other things, if you can use the fly ash, because fly ash is no cost, there is plenty is available. Or how you can have the fly ash pond to convert agriculture, because people are doing some research on the using the agriculture, but agriculture is still this is a challenge. We are not able to grow some food variety of the product. This is only for the greenery purpose people have used, but this is not coming as a agriculture product, you can say the. So this is very clearly you can see utilization is very less. So this is a challenge to our young scientists, how are going to use to have new concept. We are going to discuss one of few what I am working, but still you can have a thought, and I can tell you still very less work is happening in India, very less work. Any work if a new idea, money is not a problem, government will provide the money itself. So we have to do how can do the thing. These are the some people have started some using the fly ash, water treatment, filtration, roads they are using, building components we are using, hydraulic structure we are using, agriculture people have started to have greenery, and mine filling. So this waste material, this is utilization we are doing, so we are calling it a waste to will. I am going to give now something about the, I am skipping those things. So we have the different application of the fly ash in the concrete, and I have used the nanoparticles to enhance the concrete. Last I can say the fly ash use cement which have in the market, this is 40 MPa this strength. We have used the new composition of cement, and now SEC are going to collaborate with us. We have developed nearly 100 MPa. This is new composition of cement. I am going to give, I have already filed a patent, but I am going to give some hints to you. The new composition of cement. So now the SEC is going to complete take over our technology, and same market available cement which is only 40 MPa, we have 100 MPa, just giving very small amount of nanoparticle utilizing it. So I am not going to discuss this is a high energy ball milling a concept. People are using the different chemical methods to use the nanoparticles, but what is the advantage here? I can say the few words who are using the, this is called the two approach of nanoparticles. One is called bottom approach to have nanoparticles, another is top down approach. So this is a top down approach. What is the advantage? Here the extension of solid solubility means the two particles, suppose like oil and water, this is not miscible. If you can two systems which is not miscible, how you can make a new product? So in this system we can dope higher than the any chemical process, so we can calling extension of solid solubility. Then we have amorphous, intermetallic, this is polycrystalline, nanocrystal, nanocomposite and disordering, allowing immotional system. These are variety of sample you can get by the high energy ball milling. So a lot of people are using this high energy ball milling. Only thing this is contamination may come, but we have the understanding how much we have to grind it so that you get a final particle. So these are the some who are using the high energy ball milling. There is very simple technique. Anybody, this is not require very much the knowledge. We have the materials we have the required the mass. This is half MVA square. So depends on the mass. The velocity is 300 RPM. So which material has higher density, the impact energy of the powder transfer will be more. So half MVA. So we are using the tungsten carbide ball. This density is more than the steel. And therefore, the formation of nanoparticle is higher in this case of tungsten carbide. This is the people who have interested, they can discuss separately about the high energy ball milling concept. So this is the mechanism, what is happening, this is general mechanism, this is the progressive metal science by Suryanarayan. This is a two ball between the powder particle coming, they get collided and get the different nanoparticles. So now the concrete what is happening, this is a different kind of porous, and due to this the strength of the concrete, this is a very important pore distribution in the concrete, and this will be very helpful if you control pore. If you don't control the pore, you cannot control the strength of the concrete. So this is another method called impedance spectroscopy who are using this. This is very useful because any material will require a geometry. So this will give inherent properties. If you take any material, any concrete or any tablet, just put it. This is not require any kind of dimension. So this will get inherent property like a sugar crystal. You take a small, you take a bigger, you will get the same sweetness. So this is a very important technique to have corrosion resistance as well as the functional material properties, and people are using as a impedance spectroscopy as a very good tool to understand the corrosion resistance and the other relaxation and functional properties. So just I am showing you, this is the one MTech student results. Like the cements what we are using, what is the conductivity, how it is changing. So if you take the cement particles, put in water and see the behavior. This is very, you see the PC0 means we have a 0, then we have given 120, 240, this is time, 240 means 240 minutes, 360, these are the minutes. If you see very clear, this is the enlarge, you can see here, this is the two particles, when they are going to combine it, this become a 1. So what is happening due to these different particles in powder form, when they are going to combine, they are going to single particles, and due to this one, the strain going to increase. If the strain going to increase, resistance going to increase, conductivity going to decrease. So we are getting this two circle. This is first is coming to the grain boundary. This is a bulk, and this second circle, this small, you are looking the grain boundary. So in the particles, we have a grain boundary and the bulk. So this will say what is the contribution of the conductivity due to the grain boundary or from the boundary itself or maybe bulk. So there are different resistances coming to the picture, and we did it, take the powder, put into a specified water and put two electrode and see time how resistivity change, and this is going to be very well matched with the you can say the setting time. This is very correlated. This is the first report I can say. This is very well. So the testing of the AS standard, the setting time. If the setting time going to increase, that means the pore going to decrease and strength going to increase. This is very well correlated. This because time of lack, I am not going to explain. So some properties you can see here. We have the nanoparticle, nano SiO2. What is happening in this OPC, ordinary Portland cement? Here we have no fly ash. So what is happening if you putting nano silica? In case of OPC, we are getting the high 63.108 the MPa compressor, where you are getting the PPC, because in PPC already fly ash is more than 10% is given. So if you are giving the SiO2 already in the fly ash, SiO2 is available. If you are adding another SiO2, the calcium hydroxide which is available, the progenic effect, they are not going to utilize it, and that is the reason adding of nano silica is not going to be useful in the case of PPC, and the strength is going to be reduced. We have the different concentrations. here. So the ordinary cement, we can say, if the fly is not there, if we put a nano silica, the strength going to increase. So this is the one application I showed you, the application of nano Si2. People are also using the different particles of different concepts, but still there is a lot of scope putting in nanoparticle to increase the strength. People are using the carbon nanotube, other things, but still this is challenging for mixing those particles at a higher scale. So this is the another chloride penetration depth. This is a very important thing, because overall this concrete should be inside the different corrosive environment, and this would be how this is going to penetrate or this is less penetrate. So we have did the chloride penetration test, and we find this in case of OPC, when we put the different percentage of nano Si2, the chloride penetration is very less. So you have a 6 inch by 6 inch tube, put in a chloride solutions, this is HCl solution, and we kept it 30 days, and then we have cut it, and so when we cut it, we find this is a spar block, and what is the depth from the profile we are getting. So it is very clear this OPC is giving the more good properties than the PPC, because chloride penetration more. So when going to chloride penetration, they are going to break the concrete. So basically the gap research, I can say, till date research has been reported on the use of nano slag or flies. Slag is also coming from the plant where the steel others using. So I have did the flies, and as well as slag also I have discussing here flies. A detailed investigation of phase and mechanical durability properties of concrete contain nano flies slag is needed. Hence the present investigation is attempt to bridge the knowledge gap by using nano flies, nano slag with bulk flies and slag in concrete. So we have the, so you see these are many people did some the ball milling of 60 hours. This is some literature, and the carbon nanotube, see, the people have used by mechanical crack prevention, enhance titanium dioxide also they slate and increase the degree of hydration. Silicon dioxide they have used, zinc oxide they have also improved the processing time. Al2 nanoparticle they have improved split tensile and flexural strength. Nano calcium carbonate they are using decelerating hydration rate. Nano flies also improve compressive strength. Okay, thank you. So these are the nanoparticles applications in the flyers. People are also using to have aluminum Al2-3 to have our room using the air condition. So if you can use some kind of nanoparticle on the concrete outside or inside, so that we reduce the temperature by 5 degrees, which I don't think this is a useful for the, no need of our AC. So this is another I am giving the problem how we can reduce the temperature by using some nanoparticle in the concrete. So I thank you, because already madam given a bill. So I can keeping those things. There's a lot of things are there, but
A lot many things, yeah.
yes,
Because for a lecture, you need to have at least 45 minutes to 1
yes,
hour.
see, I
Skipping
have
all
got
these things is
to
really,
dive through this one.
yeah.
Uh, in terms of, if you see the concrete, the higher ultimate strength, increase durability, improve workability, reduce bleeding. These are the concrete installation. Then they have used the fly ash brick, but still people are using the pollution. This is another problem. People have not used much in this. They are also using the some crude oil, and they are also finding some kind of you can say the rare earth element. We have the meeting with Dr. T.S. Kumar. Now they are thinking how we can get a rare earth element from these flyers. Even this is 1%. Rare earth is very difficult. So this is another problem to find a rare earth from the flyers places. So this is one of the good problem in flyers. So thank you very much.